Okay, thank you very much for coming. So today we'll be talking about what topic here. This month is OSPF month, where we are discussing topic related to OSPF. Today we'll be talking about some areas here that are, we talk about the hierarchy, the LSA, and then area type. Okay, so let's get started. Okay, so this is the agenda, introduction, and then review some prerequisite knowledge, OSPF, and then OSPF. Actually, OSPF area, I will update the slides later, and then I'll upload it to the Slideshare. Okay, so for those who are new to GLC, we are Garda Lintas Cakrawala. We are based in Bandung, Indonesia. Our areas are training and IT consulting. We are a partner for MikroTik, Ubiquiti, and Linux Foundation. We develop our own product related to Radius Manager as well as the billing. So my name is Achmad. I'm from Bandung as well, Linux user, MikroTik user, programmer user, PHP user, PostgreSQL user, many users. Yeah, I work as a Linux MikroTik certificate consultant, writing some articles in blogs. And if you have LinkedIn account, we can meet at LinkedIn. Past experience, we do several tasks related to networking and telecommunications. Started from, build an ISP, update the technologies, integration, billing or Radius Manager into the network, and so on and so forth. Some networks are wireless and wire-based. Okay, so I can see here 9 people coming. Thank you very much. Yeah. So if you don't mind, you can just please introduce yourself here. Just put something in the group chat, telling about your name and then where you're from. Okay, so at least we know where you are. Okay, so we assume you already know TCP/IP, routing, and then routed protocol. What's the difference between them? Okay, this is necessary, yeah, because this topic is not for new. Yeah, at least you must have some idea about how routing is done in the router. Okay, so let's review. So we know O7 OC layers, and then we know encapsulation process. Okay. Yeah, from the data, and then we have segment or datagram, and then packets, and then a frame, and then bits. And then, so as you can see, we have lots of encapsulation process here. So this is what you send. So on layer 4, this is what you send. On layer 3, this is what you send. Okay, getting bigger and bigger. And this is the layer 2, normal layer 2. Okay, we assume you are using Ethernet. And then this is what it is sent if you are using 802.11. And then if you put MPLS here, the header is getting longer and longer. Okay, so that's how communication works in internet. Yeah. So we know the difference between router and routing. Router is the device. Routing is the process. Okay. Oh, I can see somebody are putting some chat here. Okay, welcome from Lagos. Hinde Adebisi. Okay, Ervin Palomero. Okay, from Philippines. Thank you. Yeah, for coming. So perhaps others are from Philippines as well. No. Okay, or from Indonesia. Usually there are people from Indonesia. Right. Okay, let's continue. So usually when we set up, okay, what is it? Alan Kessler. Okay, from Philippines. Yes, thank you very much for coming. So as I said, when we develop network, usually we set up a physical connection. We draw Okay, this port connect to that port, yeah. So we set up a physical topology, and then after that we set up a logical topology, which consists of layer 3. Okay, so we don't know which cable goes to which port. Okay, so in logical topology, you just talk about the subnet. Okay, this subnet connect to this router, and then this subnet connect to that router. Okay, and then this is how the routing table works. Okay, so packet coming, and then will be processed into the internal process of routers, and then will be forwarded to particular interface. If there is no match, and then packet is dropped. Simple as that. Okay, so this is where routing table lookup happens in MikroTik. So yeah, there is a process called routing decision. So that time, that process will do a routing table lookup. So if you have 1 million routing table entries, they will look up that 1 million. Yeah, and then usually that process can take CPU power. Okay, so yeah, if you are doing routing, and then of course there will be administrative distance, which shows that, okay, you want to go where, and then here's the distance. Of course, you want to pick a route that has lowest distance, right? If you want to go out A from from A to B, and then there are two paths, you are picking the path that is shortest, right? The lowest distance. Okay, so here are some administrative distance from several vendors, and then the way you do routing is you can do it statically. Yeah, so you log into every router and create the routing table, a routing entry. You modify the routing table by creating routing entry manually. And then here we have dynamic routing. So here you are utilizing the routing protocol like RIP, OSPF, or BGP. Here we have asymmetric routing. Okay, so here asymmetric routing means the routing is done only one way. So what we can control is we just control the outbound. We cannot control the inbound because, yeah, that's from other routers to ours, right? So especially if you are doing BGP. So what you can do is you just expect that incoming is from this interface, but it cannot be always guaranteed like that, okay? Because every router is only have capability to control their own um, outbound traffic, okay? So let's talk about OSPF. OSPF is a dynamic routing protocol. Yes, okay, we've discussed it previously. It's a link state, okay? So link, so you know link, right? So a link is defined as a connection between two nodes. Yeah, two nodes can be from host to router, from host to a switch. Okay, that is what define links, what the link is. Okay, so here the link means a connection between routers. So you have two routers, and then between them you have links. Okay, so that's why it's called link state. So it is always check about how the the link is always checking the link status. Okay, if the link is down, and then you do something. Okay. It applies Dijkstra algorithm to find the shortest path. Okay, so as the name suggests, yes, shortest OSPF, open shortest path protocol. So the OSPF algorithm will always find the best route. Okay. So here is OSPF is hierarchical. So this is important. This is our topic tonight. Okay. And then this is IGP, Interior Gateway Protocol. So this protocol will be applied in the same AS number. Okay. You cannot apply OSPF in the internet. No, usually it's for internal. So that's why it's called interior. So inside your own network. Protocol 89 used by million organizations, support load balancing. Yeah, it's possible. Yeah, I need to consider several considerations. So we have CPU processing, especially if you have lots of routers, okay, but now I don't think this is a problem. This is not a problem. I don't think this is a problem right now. So you can neglect. Why? Because nowadays CPU power of router is very high compared to maybe 20 or 30 years ago. Okay, so I don't think CPU processing can be an issue, or unless you have a very specific case where your CPU goes high because of that. Yeah. Yeah, it's a more complex. There are lots of options. So if you go to routing OSPF, there are lots of options there. Yeah. Uh, yeah. So there are lots of them, but today we'll be talking about area. So how can you optimize? So today's topic is tuning OSPF. So how can you tune up your OSPF? So make your OSPF performance much better. Yeah. So this is how OSPF works. So we use hello packets. So one router send hello packets to other router. Okay, are you there? Is there somebody here? Okay, previous week we already discussed about how to tune up the network type. Yeah, there is broadcast or not peer to peer, a point to point. Sorry. So point to point. So yeah, if you want to have a stable, so the thing actually, if everything is okay, default network type is enough. Okay, if everything is okay, but sometimes it's not okay, right? So for that condition, I would suggest not to use um, network type that is doing election. Okay, because sometimes so you have two routers here. One is DR, the other is a BDR. Okay, so when link is broken, sometimes both router are DR. Okay, can you imagine that? So yeah, when both of them are DR, they will not exchange routing to each other. Okay, so that's why people will experiencing, oh, okay, we have a connection down. Okay, we cannot connect to the internet. So that's why one of the router needs to be restarted. So for that one, you can use point to point. Okay, back to the material here. The OSPF is using um, multicast address. So if you open torch and then see 224.0.0.5, most likely it's OSPF. But I'm not running OSPF, but why do I see this 224.0.0.5? Well, it could be some of your router is running that, or some of your client. Yeah, so usually it's a 0.0.5 or 0.0.6. 0.0.6 is for DR and BDR. Okay, so what do they send? They send LSP via LSA, link state advertisement. So LSA will be flooded to all routers. Okay, and then the router generates a link state database. So when a link is down, so the LSA will be flooded to all routers. So that's the difference between link state and then distance factor. If you are using distance factor, you don't care about is the link after the your next router are down or not. Okay, so you don't know, because what you care, if you are using distance factor like RIP or BGP, what you care is just your peer. Okay, so this is my peer, this is my neighbor. So we just exchange our routing table between my router and then my neighbor. That's all. Okay, so I don't care the link after my neighbor, whether it's down or not. So my neighbor will tell me. So that's why sometimes distance factor is also called routing by rumor. So yeah, you will get update based on your peer, okay, based on your neighbor, but it's different compared to OSPF. For OSPF, when a link is down, all router, I said again, all router in that area will receive that LSA. Okay, so that's the big difference. Yeah, and then every router gets the updates, and then they will develop their own topology. Oh, okay, so at least I know the topology. So if there is a change in the network, they distribute LSP. Okay, so and the settings, yeah, area ID authentication, hello interval, that interval must be similar among routers. Okay, so as I said, BGP is internal. Yeah, internal BGP. So this is an AS number. So, oops, draw. Yeah, so you have an AS number here, here, and here. Okay. So inside AS number, you run OSPF. So this is OSPF, 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 OSPF here. Okay, so you run OSPF here, except for this guy, for this router here. So usually they are running two routing protocols. First is BGP and OSPF. Sorry, my handwriting is not good. So BGP, okay. Here also BGP and OSPF. That is for the router that is located at the edge of your network to the internet. Okay, so that's how it works. Now let's talk about OSPF area. Oh, okay, I have a chat here. Oh, okay, Alan. Oh, Jonathan. Oh, Jonathan from Philippines. Okay, welcome. Alexis Honculada. Okay, also from Philippines. Thank you for coming. Okay, some terminology. Okay, at least you know. Yeah, terminology because you will see these things in when you configure OSPF and the MacroTik. So neighbor is the, yeah, as I said, the neighbor. Adjacency, it's a condition when no routing information is exchanged. Link is link, router ID. Oh yeah, router ID is the one that is used to define your router. Okay, this is important. Yeah. So please set router ID unique. Okay, must be unique. Okay, do not put, I think your slide is stuck. Really? So my slide here is OSPF terminology. Can anybody see this? Hello. Okay, so everyone can still see the slides. Okay, so my slide here is on some OSPF terminology. Yeah, so this has to be unique. Yeah, so I have a case here when the network is weird, and we found that the some routers, there is one router that has the same ID. There are two routers that has similar router ID. That is not good. Okay, that is not good. Okay, so make sure this is unique. Okay, so router ID is like a XX, like an IP address. Okay, okay. Usually you put here on the loopback interface. Okay. Okay, so yeah, okay, I believe everyone can still follow my slides. Yeah, and then every interface has codes. Okay, usually it's it's the opposite of the bandwidth. Okay, it's yeah, not the opposite of bandwidth. So the higher the bandwidth, the lower is the cost. Okay, because we want to put traffic into the links that has a higher bandwidth. It means that we need to reduce the cost. Well, I think I just got an idea. Perhaps in the future we will discuss about the cost. Yeah, so how to steering your OSPF traffic with cost. All right. Okay, got chat here. Oh, okay. So refresh your browser and then it's good now. Okay, thank you. Oh, so you're using browser. Yeah, yeah. Yeah, it happens sometimes. And also here's the area. This is our topic today. So area is a collection of networks. Okay, so not collection of routers. Okay, so perhaps it's different compared to BGP. So BGP is S number is a collection of routers. Okay, so area is collection of networks. Networks means prefix. Okay, so that's different. So this prefix belongs to this area. This prefix belongs to this area. Okay. Okay, so let's continue. When we do OSPF, usually we have several router type here. So we have ASBR. So this guy, okay, so it's a border router. This is the internet, okay, and then for example, this is your AS. Okay, so the router that connects to the internet is called ASBR. And then here you have ABR, so which is this guy. Why? Because you have area 0 here, and then here you have area 1, here you have area 2, here you have area 3. Okay, so here you have an interface over here. So there is an interface here, there's an interface here, interface here, interface here, interface this one, interface this one, interface this one. So if the router connects to two different areas, it's called ABR. Okay. If the router inside that area, it's called IR, internal router. Okay. As simple as that. Okay, so looks scary. So that one was just a typical high level diagram. So okay, perhaps we can put here more details. Okay, so here we have a router 86. So what we call here. So let's say this is all one AS number. Okay, so this is called ASBR. Okay. And then here, all here are the routers. Okay, and then here's the PC. Okay, so all of them here in one area is called area 0. So that means if this link is down, this router will send to any other routers. So as you can see, there will be lots of LSA here. So lots of processing. Okay, so LSA. Okay. So why do the LSA send to all router here? Because all routers are in the same area. Okay. Yeah, so especially if you are using PPPoE, sometimes PPPoE, if you put PPPoE network into your OSPF, right? Yeah, some of you might do that. For that one, when the customer login or authenticated, they will get an IP address, and then at that time we can say that one link is established. When the PPoE client is established, it means that there will be one virtual interface created in the MikroTik. Okay, so if one interface is created and then the interface has an IP address, it means that the link is up. If the link is up, it means that we need to update the topology, okay, because there is a change in topology, even though it's just only one link. So it means that I have to send to every router in my area. Okay, so if you have a PPPoE here, for example, connected to this one. All right, so that's how it works. Okay, so at least you need to understand how it works in the high level. Okay, so is it possible that we have more than one ASBR? Yeah, it's possible. Okay, so you have two ASBR like this one. So how do they go to the internet? It depends. That's the function of uh, that's the purpose of 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 um, of what is it? Of cost, yeah, COST. Okay. So you have here, you have a default route, right? 000/0. Yeah, this is called default route, and then this default route is classified as external route, not internal route. Okay, and then we can define whether it's defined as external one or type 1 or type 2. Okay. I forgot the difference, but one of them is you include the internal cost in total, and then the other one is just consider the external. Okay, so this is one cost. Okay, and then here and there. Yeah, so depends on the cost. Okay, the lowest the cost, yeah, the preferred path to go to the internet. Okay, so here it is. So it is possible to have two ASBF or 3 or 4 ASBF in your router. Okay, again, all of these router are including this. Okay, are area 0. Okay, yeah. So that's the issue when we do well. Sometimes we just use one area 0, to make our life easier. Yeah. Yeah, it's very simple. Yeah, but like what I said, when you have several network here, for example, PPPoE, when you have PPPoE is using /32 network. Yeah, so it means that when the PPPoE is active or not active, it will send to every router in the area. So that means it's not good. Okay, so what we do, we set up the area. Okay, so this routers, oops, sorry. So again, an area, it means a collection of networks. So it means that this area, yeah, it means area 11, area 13, area 15, 17, 19. You can just use other areas you like. Okay. And then what about the area 0? Yeah, so this is area 0, aka backbone. So this area here is called area 0. So that means if so the way router 61 goes to router PC 65 here, the way it does is it goes to here, to area 0, and then here. Okay, let me repeat. From here to here. Okay, that's how it works. So that's why it's called hierarchical. So if you want to connect between area, you have to go through area 0. Okay, even though if you put a cable here, if you put a cable here, okay, you think the traffic will go this way? No, it's not. Okay, so the traffic always go to area 0. So that's why area 0 is called backbone. Yeah, you know, it's like a human backbone. We have a backbone, and then on that backbone we put many organs. Yeah, so because the backbone is very strong, yeah, so that's why it is a place to put uh, many organs there, or many skeletons. Yeah, so same idea with the area 0 here. Okay, so all traffic from other area, if they want to go to other area, they have to go through a backbone. So that's the hierarchy in the OSPF. Okay. Well, yeah, that's how it works. Okay. So what's the benefit of using the area here? The benefit of using the area is to reduce the LSA. As I said, if one link here is down, and then this router will send LSA to its own area. What about the other area? So that's why it's called the summary. So this router, this router is called ABR. This is also ABR. Yeah, so this router will send the summary of my own router to others. Okay. So that's different. So if you have PPPoE here, okay, so that PPPoE will be broadcast here, and then the summary will be sent to other routers. As simple as that. All right. Any questions so far? Yeah, so that's the tuning. Okay, so if you want to tune up your OSPF, well, I would suggest you to move from one single area to you split it into several areas. But you have to carefully plan that the backbone has to be a very strong network, okay, because that's the place where all traffic goes. It has to be strong. The router has to be strong as well, high specification, and then the bandwidth must be available enough for carrying all other traffic from other area. Right? So questions, you can put question in the group chat. I will, yeah, if you're interested, come to our training. And then this is the end of slides. Feedback is available on here. Okay, let me put. Also, you can write the feedback here. You can put the feedback and then put some topics that will be discussed in the future. Update will be available on our website. Facebook page is available to put our announcement. Slide will be available on Slideshare. Discord also, we have Discord but in Bahasa Indonesia. Recording will be available on YouTube. Okay, so let's try something with the microtik. About where you put your own router. It's not working. Uh-oh. Will this be available on YouTube? Yes. Okay, let me connect to my network. Okay, please wait a moment. Yeah, so I have issue with the connectivity to my network here. Please wait a moment. Why it's not working? Oh yeah, here. Okay, can you see my router here? This is my test router. Okay, on CHR. As you can see here. Oh, okay. So I need to change. Yeah. I need to change the screen share. Okay, you should be able to see it by now. Okay, right. So this is OSPF. Okay, so this is my test router. Oops. Okay, so so this is instance. Blah 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 blah. So make sure this router ID is unique in your network. Okay, so you can define your router ID here. Okay, this example, and then here's your area. Okay, so here's the area. So first is the instance. So I put here instance 1, and then the area I put here instance 1 area 0. Okay. So is it possible that you put more than one instance? Yes. Yeah, I usually use it to route other traffic so that it will not disturb my own OSPF. Understand? Yeah, it is possible. Yeah, so we can set up like, so this is my own OSPF. Instance number 1 is for my own OSPF, but there is my customer wants to forward their own OSPF traffic through my router. Okay, so that's a case study where you need more than one OSPF instance. Okay, so instance number 1 for my own OSPF, instance number 2 for my customer OSPF. Yeah, it is possible. Yeah. So this is, as I said, this is the area 0. Okay, you can put the area there. Okay, here's the instance. And also here's the type, okay? NSSA, and then this is a stub area. Stub area means you're not allowed to put external route in your area. But not so stubby, it means that you can put, so that's the only difference between not so stubby and then stub area. Stub area means it's very strict, no external routes allowed except from the ABR. Okay, so if you do RIP in your stub area, it's not allowed. Okay, the OSPF will reject. But with NSSA, you can combine OSPF and RIP in your area. Okay, so this is how you define area, and then here's the non-area zero. So this is how I put. Okay, so area here, and then I put area this one. Yes, you can put area 11, area whatever. So it's up to you. But I usually put like this. So to define that, okay, this area is for this prefix. Okay. All right. So yeah, that's all. So as you can see, this is the interface that we are running. Okay. And then here's we have this is a static neighbor. If you are using NBMA, you define here. And then here's the neighbors. Okay, here's the neighbor status. Okay. And then here's the LSA. Oh, for the course is available here. Here course. Okay, so here you are using template. Okay, so I put here, as you can see, so I put template for different area because this router here, this router is ABR. So this one goes to area 0. This interface goes to area 10.40.27.0, right? So this template goes to here. This template goes to there. Okay, so it's up to you how you define the course over there. Now, for example, on this one, the course is 1 and others will be others as well. Here you can define authentication, blah, blah, blah. And yeah, that's all. I think in version 7, I already get used to the setting here. And I think with the template here, it is easier to define the settings, because as you can see, you can define here more than one interface. Yeah. Sometimes in the version 6, if you have more than one IP address in one interface, MikroTik only defines one of the IP address for link. Yeah, and then it's not good. But in version 7, they can accommodate that. Yeah, by, for example, by specifying the specific IP address for connectivity, like this one. Okay, so they're not only, oh, okay, this interface. Okay, so here's the interface, but I'm using this IP address on that interface. Right? So yeah, that's all. Any questions? Any questions? So I hope you enjoy the webinar. And I think that's all. It's been almost one hour. Yeah, if you don't mind, so I will take a picture. Okay, so please turn on your camera. Yeah, I'm gonna take some picture here. Okay, everyone. Okay, put your handsome face here so that I can take a picture of you and then post it on the internet. Right. Okay. 1, 2, and 3. Yeah, smile, man. 1, 2, and 3. Okay, thumbs up, thumbs up. Okay, 1, 2, and 3. All right, guys. So hopefully we hope you enjoy our webinar here. At least you get an idea about how to tune your OSPF, especially if you have a big network that has lots of routers, and then big network that has links like PPPoE. So that way you can optimize your OSPF network by splitting the big network, not the big network, the big area, the area 0 into smaller areas. Well, I think that's all. Again, thank you very much, and then see you in the next webinar next week at the same time, Thursday evening, 19:30. Right. Thank you very much, and then see you later.